Hello. Smart contracts are programs running on the blockchain, the most dominant of which being the Ethereum blockchain. But what is a blockchain and what is cryptocurrency? We heard the terminology. Cryptocurrency is some sort of magic internet money. And this magic internet money runs on the blockchain. You can think of this as a distributed ledger, just like the one that is in your town hall, a public ledger, and it keeps track of all property ownerships over the past couple hundred years. And just like this ledger, you only own an asset because this ledger says so. Assets are transferred by updating this registry with the new owner. And on the blockchain, this transaction is signed cryptographically by the previous owner. So all of this should be safe, right? Yeah, except that in the Ethereum blockchain, all of the things are programs. They're called smart contracts. In fact, the registry, which keeps track of ownerships, is a program. You can look on the right-hand side, and you can see that there are some major cryptocurrencies that are implemented as Ethereum smart contracts. The holders of these valuables, these cryptocurrencies, the holders of these, they can also be programs, even though you would think that accounts should be rather simple. All of these programs are stored on the blockchain, and there are many complicated programs out there, things like exchanges, currency issuers, market makers, brokers, all of these programs. So there's a huge potential of bugs wreaking havoc on all these systems. MadMax is a bug finder, but it detects a particular kind of bug, one that only occurs in this new domain. It also offers powerful static program analysis, that is, algorithms to detect bugs at a code level to find these sorts of new bugs. All these bugs have to do with gas. And gas is something, it's a concept which is introduced in smart contracts. It is a fee that is paid by a user in order to interact with smart contracts. In a nutshell, you pay a fee according to the instructions that you execute. Why do you need to pay a fee? Because otherwise, if you don't, one can simply run a lot of pointless computations on the blockchain and thus clog down the entire network. So it keeps the network safe from denial of service attacks. But this mechanism also introduces an unwanted behavior, one that I'm going to be demonstrating here with a very simple example. So here there is a smart contract called Naive Bank. It contains a list of accounts and it has a function apply interest. In this function, the program iterates over all the accounts and increases the balance by approximately 5%. The smart contract also has a public function called open account. And since this is a public function, everybody on the network can call this. To cut to the chase, the problem is that every iteration consumes a substantial amount of gas. And by the time the accounts array is a couple of hundred elements long, you can no longer call apply interest because the amount of gas you can call in a single transaction is bounded. So a malicious user who wants to stop apply interest from executing can simply just open a bunch of accounts, a couple of hundred, and thus prevent this functionality from executing. Now this kind of reminds me of the Christmas Carol, the 12 Days of Christmas, where the number of gifts starts off reasonable, partridge in a pear tree, and it increases every day in this carol. Well, thank God that this carol only went for 12 days, not 120 days. And you do not want smart contracts designed that way. Now, the MadMax implementation looks a little bit like this. And what's this? Well, it's a static analysis, but it's implemented using mathematical logic rules. It's implemented in a language called Datalog, and using this language, we have defined a vocabulary of concepts that capture program behavior. Things like publicly accessible functions, loops that iterate in unbounded ways, and so on. Isn't this slow? No. In fact, out of this specification, we can synthesize a very efficient C++ implementation, which is so fast that it has allowed us to analyze the entire corpus of smart contracts, basically all the smart contracts ever deployed to the Ethereum blockchain, in under 10 hours. We have been able to flag a lot of contracts for these kinds of new bugs with a very high precision. If you're interested more in this work, please read the article on communications of CACM.